Morning, my dear students. I, Annu, welcome you all to the online class of chemistry. Chapter 1, Part 1, Matter. My dear students, in this chapter, we would be studying about states of matter. What is matter? What causes the difference in the states? What is interconversion of states of matter? And about the kinetic theory of matter. So let us begin. My dear students, as you can see in this presentation, that the first slide is about that there are three states of matter. But before that, all of you are already aware what a matter is. So I am going to help you to revise or recall that. Anything that occupies space and has mass is called matter. So there are three states in which the matter exists. That is solid, liquid, and gaseous. In this presentation, students, you are able to see what are solids, right? The various examples of solids are shown here in the presentation. Similarly, these are the example of liquids, and we have the example of gases. These are the basic example of the three states of matter. Under solids, we can have table, snow, apple. All these things are solid in nature. Under liquid, we can have hot chocolate, rain, milk, drink, juices. In gases, we have wind, air, steam. All these are the categorization of gases. So these are the three states of matter. Moving ahead, we have a brief introduction to what a solid is, what a liquid is, and what a gas is. My dear students, let us talk about solid first. In this picture, you can see the first picture it is of solid, and the red color balls, these are the molecules that are indicated by, that are indicating the solids. The force of these molecules in a solid are held by a force that is called as intermolecular force. And the space, as we know that in case of solid, the molecules are tightly packed, so we could not see any of the space between these particles of the solid. That means they are held at one position. So the space that is between the molecules, it is called as intermolecular force. It is called as intermolecular force. So by looking at this, we can see that the solids are rigid. They have a fixed shape and they have a fixed volume. Why? Because the molecules in case of solid are so tightly packed that they vibrate only at their positions. They cannot move from one place to the another. They are tightly held by the intermolecular force. Whereas we talk of liquids, we can easily see here the molecules in a liquid are not as tightly packed as in case of solids. We can easily see the space between the molecules or the particles of the liquid that is called as the intermolecular space. And the force with the help of which the particles are held, again, it is called as intermolecular force. So the force in case of liquid is not as strong as that is in case of solids. So while we talk of liquids, the particles in a liquid can move but little bit. Right? They can move from their position but very little. Since again they are also held by the intermolecular force. The liquids are not rigid, that means they are not as hard as solid. They do not have a fixed shape, right? We know that whenever we pour the liquid from one container to another container, the shape of the container, the liquid takes the shape of that container. Okay, then the volume remains fixed. Suppose if you are pouring 5 ml water from a bowl to a glass, it is going to remain 5 ml. So the volume is fixed, but it does not have a fixed shape. Now, while we talk of gas, my dear students, we can easily see in the picture that the molecules in the gas are free to move, right? We can easily see there is a lot of space between the particles of the gas, or the molecules of the gas are free to move in all the directions. That is, the intermolecular force in case of gas is least. The intermolecular force in case of gas is least. That is why gases are not rigid. They do not have any fixed shape, neither they have a fixed volume. You know that when we talk of air, the air is free to move in the entire room, right? It does not have fixed volume, nor does have its fixed shape. So that was a brief introduction to the states of matter. By this, my dear students, you might have understood what is a solid, liquid, gas, and how is the arrangement of molecules are there in the three states of matter. Seeing further, now, what is the reason that is causing the difference in the states of matter? What is the cause? Why there is a difference in the states of matter? So for this, we have two important factors, right? The molecules which make up the substance do not change in the three states. In fact, the force and the space between the molecules determine the space, determine the states of matter. Remember that, please. The molecules that are making any of the substance, it does not change. In fact, the force and the space that is between the molecules that determine the state of matter. So let us see what is intermolecular force first. The intermolecular force of attraction is the attractive force that causes atoms or molecules to stick together. That means it is that force which helps the molecules, or which try to hold the atoms and molecules together. So that is the stronger the intermolecular force, the smaller the intermolecular space. Both of them are contradictory to each other. The intermolecular force, it is strongest in the solid state. Remember that. It is strongest in the solid state. And why it is strongest? Because we know that in case of solid, the molecules are not able to move themselves. They are at the one particular position. They remain fixed at the one position. So that is the intermolecular force. That is the force of attraction that causes atom or molecules to stick together is called the intermolecular force. Now, what is the second factor? Intermolecular space. While we talk of intermolecular space, space between the two particles of matter are called the intermolecular space or interatomic space. So intermolecular space are very small and solid. I have depicted already in the first picture. In my first slide, the molecules in case of solid are so tightly held. We cannot see any of the space between those molecules, right? So that is, it is intermolecular space in solid is very, very small. The particles of solid matter are very close. So this region solid has high density and incompressibility because there is no space between the molecules of the matter. While we talk of liquids, my dear children, we know that in case of liquids, the molecules are not as tightly packed as in case of solid. So the space in case of liquid is slightly more than that of solid. And gases, they have a very large intermolecular space. Here, my dear children, you can see that it is shown for the intermolecular space. Gas has the most intermolecular space, then liquid, and then solid. That is why the gas particles are free to move in any direction, because the space is very much and the force is very less. The force of attraction and the space differ from substance to substance, but for any of the substance, both of them are contradictory. That means if intermolecular force is going to be more, then in that the intermolecular space is going to be less. Both are contradictory to each other. Both are contradicting to each other. The molecules are most tightly held in solids, then they are less tightly held in liquids and almost independent of each other in gases. So that is the reason which causes the difference in the three states of matter, that is intermolecular force and intermolecular space. Now let us learn about interconversion of these states of matter. I think by diagram it is clearly understood that I can convert solid to liquid, liquid to gas. But how the conversion takes place? We know that the arrow indicates that even I can convert solid directly to gas and gas to solid, right? I would be explaining, my dear students, each and everything to you of this presentation, of this particular slide. We know that on heating, ice turns into water and water into steam. Whereas if we cool the steam, it turns into water and water to ice. So we can easily say that interconversion of states takes place on heating or cooling. Now, when we heat the solid, it changes into liquid. So the process is called as melting. The process is called as melting. The constant temperature at which a solid turns into corresponding liquid, that is called as the melting point. That is called as the melting point, right? Similarly, I can convert the liquid to gas. So when the liquid gets converted to gas on heating, that is called as vaporization. That means liquid has been changed into vapors. So it is called as vaporizations. Vice versa, I can convert gas to liquid by cooling. I can convert gas to liquid by cooling, right? See, this is the arrow in the forward direction and this is the arrow in the backward direction. So it clearly indicates the processes are reversible to each other. So when I change the liquid to solid on cooling, that is called as freezing. That is called as freezing. The constant temperature at which the liquid freezes or changes into corresponding solid is called as the freezing point of the liquid. The freezing point of the liquid is same as the melting point of the solid. And the constant temperature at which the liquid boils, that is called as the boiling point. And as you cool the gas, it can change into liquid, that is called as condensation. So when the gas is cool, it changes into liquid, that is called as condensation. And I can convert solid to gas directly without going into the liquid state, so it is called as sublimation. Similarly, the vapors or the gas on cooling can give us back the solid, so that is called as reverse sublimation. So this is how the interconversion of states of matter can take place by heating or cooling any of them. I hope it is clear to everyone. Now moving ahead, we have the kinetic theory of matter. The kinetic theory of matter, my dear students, explains the behavior of the three states of matter. It tells us how the molecules or how the solid or the liquid behaves, right? It makes us understand the behavior of the three states of matter. So let us start. All the matter is made up of tiny particles called as molecules. All matter is made up of tiny particles called as molecules. Moving to the next point. In the solid state, the particles are rigidly held in their positions. Why? Because it is the intermolecular force that helps to bind them at one position. They can only vibrate at their own positions and cannot leave their position and move from here to there. Third point, in the liquid state, the particles are in continuous motion. They are in continuous motion, but they are not completely separated from each other, as the intermolecular force again holds them, but it is not as strong as that in case of solid. So while motion, they collide with each other. While motion, they collide amongst themselves. So in liquid state, the particles are in motion, but they are not completely separated from each other. They can collide amongst themselves. Coming to the fourth point, we have in the gaseous state, the particles are in continuous random motion. That means they are independent of each other. They are free to move. The intermolecular force is least and the intermolecular space is maximum in case of gaseous states of matter. The particles in a gas travel much more longer distance than in liquid before they collide with the other particles or the walls of the vessels. We know that the particles in case of gas, they can travel a longer distance. Why? Than in case of liquid. Why? Because they are not tightly held, as in case they are not held so strong like in case of liquid. At least in liquid, the force binds the molecule. It does not help them completely to separate. But in case of gaseous, they're free to move in any direction. So they collide with the particles of the wall of the vessel in which they are contained. Okay, they can move a very long distance. The gaseous particles can move very long distance than the liquid particles, since they are not held as tightly as those of liquid particles. The collision of the particles with the wall of vessel give rise to the pressure of the gas. So as the particles of the gas, they collide with the walls of the vessel, they give rise to the pressure of the gas. So finally, as the collision takes place with the walls, it leads to the rise in pressure of the gas. Moving ahead, we have the collision of particles with the wall of vessels give rise to the pressure of the gas. Then the particles possess some energy due to their motion, that is called as kinetic energy. So the energy that is possessed due to the motion of the particles, that is called as the kinetic energy. Remember that kinetic energy is always associated with motion. Last point, we have the kinetic energy possessed by the particles is dependent on temperature. The kinetic energy possessed by the particles is dependent on temperature. How it is dependent, my dear students? The higher the temperature, the higher is going to be the kinetic energy. Lower the temperature, the lower is going to be the kinetic energy. That means both of it are directly related to each other. If you increase the temperature, the kinetic energy is also going to increase. If you decrease the temperature, the kinetic energy is also going to decrease. So these are the 6 points which can be said about the kinetic theory of matter and which help us to explain the behavior of particles and the 3 states of matter, that is solid, liquid and gas. So this was all about this part, my dear students. Please go through the presentation again so that you can understand it in a better manner. And please read the chapter thoroughly. And very soon, the part 2 would also be shared. So please go through the presentation and make your concepts clear. Thank you, my dear students, for watching this presentation. Thank you so much.